Hello, welcome back to this class. The topic of this class is transformer. This class is about advanced artificial intelligence. This is part one, and there are more parts coming for this class. I'll go through the transformer part by part for two components, encoder and decoder. So what's transformer first? Well, basic definition of a transformer is that it's a neural network architecture which was coined by paper Attention is All You Need in 2017. Basically, transformer has two parts. The first part we call the encoder or reader, which reads and understands every input. And the second component is called decoder, which is, we call it writer, and which writes the output basically. So that is encoder, reader, and that's decoder, writer. Well, the exact structure or architecture of transformer completely relies on the particular task. Well, some models could have only encoder, and some other models could have decoder, but there are more models they can use both. So this is basic structure of encoder and decoder. So the left-hand side is encoder, which is reads the input, input embedding, multi-head attention, add norm, and then feed-forward neural network, add a norm, and then encoder. The encoder will come into decoder, will be combined with the context or the sentence from the encoder. So again, encoder could have so many layers as you can see, but the last layer is linear and softmax. Now, transformer, basically, the definition of transformer basically processes the input sequence and creates a rich contextual representation of every single token or input token. For example, if we have a sentence and that sentence, the cat sat on the mat, the encoder converts every word into embedding and then allows each word to look at each other using self-attention. For example, sat attends to cat, mat attends to on, and the article attends to nearby words. As a result, each output embedding contains information about the entire sentence. Now, we have the encoder structure, which contains input embedding, positional encoding, multi-head self-attention, add and layer normalization, feed-forward network, add and layer normalization, and output. Usually for larger language models, they may have 6 to 24 encoder layers. Now, self-attention, this is a basic brief explanation about self-attention. In next parts of this series of videos, I will explain the equation, providing the examples or practical examples, how to use self-attention. So for now, we have three components: query, Q, key, K, and value, V. This can be found by this equation, subject to softmax function. So this lets every word determine which other words are most relevant. Transformer decoder, we say this one takes the role of writer, writes output sequence token by token at a time. Uh, for example, if we have in English a sentence, how are you? And in French, translation in French could be comment allez-vous? The decoder predicts comment and then comment allez-vous, then comment allez-vous. So word by word can be translated. Now, decoder also has some layers, and we'll talk about each layer in detail. Previous output tokens, positional encoding, masked multi-head self-attention, add and layer norm, encoder-decoder attention. That is the input that comes from the encoder and will be combined with the decoder component. Add and layer norm, feed-forward network, add and layer norm, linear and softmax, next, and then next word. Now, why do we need self-attention? Well, decoder should not use future words, should not see and use future words. For example, if you have a sentence, I love AI, when you predict love, then decoder should not see AI word, should only see the word before love, I. We said it, encoder, it's a reader, reads the entire paragraph, understands its meaning, creates notes summarizing every sentence and how they relate to each other. Decoder, the role of it is writer, uses those notes, writes the translation one word at a time, and refers back to the notes whenever needed. Here, for models that we have, the comparison of the models that we have BERT that uses decoder, mainly does text classification, sentiment analysis. GPT mainly use, so BERT uses encoder, sorry. GPT uses decoder, it can be used for text generation and chatbots. T5 uses both encoder and decoder. BART uses both, mainly handles the task of summarization, text generation, rewriting documents, and things like that. So this is for this class. For further information, you can check those links, and I'll see you in the next class. Thank you very much. Take care.